This is SOLIDWORKS 2011 Week 7 Concepts from Chapter 5, adapted from Learning SOLIDWORKS 2011 Project-Based Approach. So today we're going to look at these Chapter 5 concepts. We're going to look at thin features, both extruding and revolving. We're going to look at creating dome features and split lines, chamfers, lofts, multiple thickness shells, and also creating different configurations for your parts. So we're going to start with thin features. And this is a feature that is a thin wall of a constant thickness. So to create this feature, we just need to do a simple sketch. It can be closed or open. But the one constraint is that the sketch needs to be a single curve, so it can't have any branches on it. And so you can see from the good examples here that we can have a simple closed or open sketch, even something kind of complicated. But it won't work if we have something like this where there's a branch, this kind of Y shape, or if we have multiple closed sections, the solver can't work with that. To see what this looks like in SOLIDWORKS, we're just going to go to create extruded boss/base. And I want to show you what happens if we start from the feature creation first. So not creating a sketch first, but a feature. Let's say I want to create an L-shaped section. So I'm not going to worry particularly that it's not perpendicular. We can see that because I left the sketch open, it assumes that I want to do thin feature. So then when I extrude, let's say I'm going to extrude this, we'll make that 2 inches. I can specify my thickness to be, something consistent across the part. And here I specified 0.2 inches. And I can also specify which side I want the thickness to be specified. So I can do mid-plane, in which the thickness is evenly split to the inside and outside. I can do one direction and then flip which side I want. Or I can do 2 independent directions and specify different thicknesses. So all of these will ultimately give you a single thickness of part, but it just gives you more control over what shape the part will take. If I hit accept, you can see now we have this L section with a consistent thickness through its part. I've rolled back the sketch, so now we're going to do the same thing with the revolved section. And we can do this either by clicking the revolved base or just create a new sketch in the direction we want. So for this example, I'm going to work on the front plane. And like with other revolved sections, we want to first draw a center line just so we have a reference to work against. And let's say I'm going to make a frisbee shape. So we'll draw a line, and then we can use, take advantage of our tangent arcs, basically. Let me back this up to get a bit better start. So we'll start from here, draw a vertical line, hit A to create a tangent arc, and then another line. So I'm not going to bother with dimensions, but we could add a diameter and whatnot to show this. And now with this sketch drawn, I can go to revolved boss/base, and then it'll ask me, a non-thin revolution will require a close sketch. So we don't want to automatically close it because we're going to specify a thin feature. So again, we have one continuous sketch. And you can see now that the thickness is extruded from this preview. You can see it's extruded inward. I can flip it to extrude outward, or choose mid-plane to have this be the center profile. And then when I hit check, I now have that frisbee shape. The next feature type we're going to look at is using a dome feature and a split line. And so the idea of these guys is basically we're going to modify the surface of an existing solid. And to draw a feature on a flat solid, we're basically going to end up dividing a face into multiple sections. And so the split line is going to be the means that we use to actually create 2 faces from what would otherwise be a single face. So when we're sketching a dividing line to do a split line, we want to draw a closed section, and we want to draw it in such a way that when it intersects the face we want to split, it produces 2 valid closed faces. So what this would look like on our frisbee model here is I can draw a simple sketch on the surface. And let's say I want to split this round face here into an outer face consisting of this region and an inner face, which is this rectangle. So I've drawn this sketch. I can go to features, and so we want to choose split line here. And so that's under the curves drop down. And we have a couple of choices here. We can do silhouette, projection. Typically, if we're going to do a sketch, you're going to want to choose projection. We're going to choose a face and a sketch. Hit accept. And now we have a split line. You can see if you hover and even select the faces, you now have, even though these faces are coplanar, in other words, they lie on the same plane, they are two independent faces. Now, if you want to create something like a dome, you can use a single surface, and you can then have an independent shape. We can see we have a rather dramatic dome here, but we could do something a little more conservative, and so we can see this dome feature, which is just a raised rounded part, comes up only on this surface and not on the whole surface here. So, and you'll find there are many other features such as ribs and drafts and such that will take advantage of this, but for now, that simple technique of sketching a dividing line that's a closed section, splitting a face, and then creating other features off that face is going to be very useful. We're next going to look at chamfers. And so it's a pretty simple concept to explain, so I'm just going to flip right over to the SOLIDWORKS window. I'm going to start from this model I've loaded, which is it's basically a hex nut shape. We have a hexagonal simple extrusion. It's about 1 inch thick, and then I have a hole cut in the middle that represents the threaded hole. So chamfers are similar to fillets in that, just like fillets, you select edges. You specify the properties of the chamfer. So in this case, you can specify an angle and then a distance. And from that, you can see that we have a distance between these two edges specified as 0.1. The angle is 45 degrees. You can see what this looks like. It just chops the edge off of this. So that's the simple chamfer that you're used to. However, I want to point out that the angle distance method doesn't always work, in particular for situations like this hex nut, where you have the problem of these edges that don't meet at right angles. So that 45-degree assumption is going to break down. Let's say if I choose this edge, for example, you can see that we've created a 45-degree angle between the one surface, but this leaves us a very ugly asymmetrical chamfer on the other surface. So what we want to do to fix that instead is use either distance, where we specify a distance away from each edge as 0.1, or you can specify equal distance and again control it with just 1. So often this is going to be the kind of chamfer you're going to want to use for these different angled faces, just an equal distance, and then you can specify a single value like 0.15. And so then you can see I can select all of these edges to go along with it and get and I'm going to set that back to 0.1. We can get a nice break to the edge. And so now this looks a little bit more like a hex nut. Now, we can also chamfer the tops as well. And the sequence that you chamfer is going to be important. You can see I'm only selecting the major edges. After I've chamfered these sides, I can show a full preview if I want. So using that same setting here for thickness, 0.1 inch, and here since I'm doing perpendicular edges, I can get away with 45 degrees. I can apply this top chamfer, and now we have this nice uniform meeting of these three chamfered edges. So generally when you have chamfered edges coming together, this is what you want to see. Symmetry, uniformity, and it looks about like what you'd expect if you hand filed this part. We can also chamfer non-straight edges as you might expect. So for example, sorry, I'll do that again. We can select the inside of these edges. So much as typically the start of threads on a nut is going to be chamfered like so. So we can add that as well, and now you have essentially the shape of a hex nut. So to quickly review, when you're creating a chamfer, it's going to be under fillet. You basically just have to specify the edges that you want to chamfer. You want to choose a method to do the chamfering, be it angle and distance or distance and distance. And that's pretty much it. Just make sure that you specify chamfers in a reasonable sequence. Try and avoid like chamfering chamfers just because at some point it will break the solver. And that's basically it. So this brings us to the next set of features that are going to be very powerful and a bit difficult to use at first. These are the so-called loft type features. And the idea of a loft is just to create a smooth blend between two or more sketched profiles. So let's say we have a drawing of two different shapes. Let's say like a circle and a hexagon, or two different size circles, or perhaps even like a square and a rectangular shape to a round shape. What the loft feature will do is, starting from one side to the other, will identify key points on that sketch, on each of the sketches, and draw connecting lines between them. And then treating each line segment that's been cut out and those connecting lines as a surface, it basically creates like a blended surface in between, which gives you an interpolated version of the surface between each of these sketches. Now, that's kind of a mouthful to take in just verbally, so let's see what that looks like on an actual model. So I'm just going to simplify this. I'll suppress the other stuff we did, and then we will create a reference plane. And I'm just going to do this very quickly using an offset of about 2 inches from this top surface. And then here I can create a sketch placed on that plane. And for now, we'll just draw a circle that's near the size of the hexagon. The exact size doesn't matter. It could be bigger or smaller. It's like I could make it like this size, for example. And then I'll hit accept. And now I should be able to, if I am remembering this correctly, that is. We'll select these two surfaces, click lofted boss / base, and you can see it takes the face at the end here and smoothly blends it into this final shape. And this grid that you see here is showing you the effect of interpolating from this edge here along these lines to this edge here. And you can see each line that connects it becomes a little bit more round until finally it looks like this. Now, when you're going to a round shape, you tend to get very nice blends because you can easily divide this circle into these sort of key points here. You don't see the points themselves, but you can see the intersection between these lines, and it does a reasonably good job of making that smooth. Now, we can also show the effect of what happens if we play with those connecting lines. We can rather drastically affect the final shape by changing the angle that these connecting lines creates with the basically the direction of the loft. So by having the connecting line straight out, you get this straightforward blend, but you can also get this sort of kind of crazy twisting, almost an iris effect, just by dragging the connecting point around. Now, you can, of course, take it too far. If the section self-intersects, it won't solve, as you can see. But for the most part, you can create a pretty impressive variety of shapes just from this very basic specification. Now, a word of warning, it can be difficult to dimension something like this and represent it clearly. So unless you're doing something that's cosmetic, you may want to try and minimize the amount of, basically the amount of twist or the amount of features that are hard to inspect. Anyway, we accept this feature, and you can see the final shape. It gives us a smooth blend between the two. And you can do this with multiple sections. You can do it between a round and a square. So for example, if I do yet another reference plane, and I will draw a sketch on here, you can see even if this sketch is, fairly exotic looking, it should still be able to solve. So I'll do like this home plate shape, still of course constrained to have a closed section. And with this sketch and this top surface, I'll create another lofted plane. You can see that by default it doesn't seem to understand what we want because of the location of this drag point. But again, by connecting the point from the round to the edge here, it figures out what we mean. And so at this point you can see that it's had to sort of abandon this point as well. So you'll see this face here is a little bit bigger than the others. And so you don't get, even though this should be, you would expect this hexagonal feature to be symmetrical, this blend does not produce a symmetrical result, even more than you would expect from this slightly skewed shape. And that's because it has to basically merge this additional point onto this face. So try and keep that in mind. That's another important point for lofts. The number of, shall we say, key points around the side of each sketch should be about the same to get the best results. You can see that result here. Still produces a valid solid. It just might not be exactly the shape you want. So we can also use this shape as a demo for our next set. So I want to talk now about shell features, in particular using multi-thickness. So in other words, specifying multiple thicknesses for each shell face. So the sequence of operations is pretty straightforward. We're basically going to choose a set of faces that we want to completely remove, the thickness of the shell that should remain. So in other words, if the part solid walls were only, I'd say 0.1 inches thick, you would specify that thickness. And then you can select another set of faces to have a different thickness, and finally specify that. So this can be very straightforward to do. So basically, we apply a shell. As I said, we specify faces to remove, let's say for now the ends, and I'll leave the thickness to be 0.1. And then for multi-thickness, we can say choose a sequence of faces like this to have a thickness of 0.2. So it'll chug along, and we can see the effect is that we've removed these end faces, and we get this nice 0.1 inch thickness around the side, except for the stretch of faces that we chose as a multi-thickness. That you can see as this extra thick section for 0.2. So you can choose an arbitrary set of faces to produce that extra thickness, but that can be really useful when you have, let's say, a counterbore on a round part, like a thin extruded part, or anything like this where there's the section is a consistent thickness except for a few simple spots. Finally, I want to talk a little bit about configurations. And what these are just, it's a quick way to specify different versions of a part within the same part file. So it's a very simple trick. It uses something called feature suppression. And basically a different configuration is a set of features that are suppressed and not. So by choosing a configuration 1 or 2 or 3 or whatever, you're deciding, okay, my first feature is going to be suppressed and my second feature won't. And so you can quickly swap back and forth between a given combination. So what does this mean in terms of, let's say, this part we have? So I'm going to just delete this shell feature. Let's say I want this part exactly as we see to be one configuration. Well, I can flip to my configurations tab, and then maybe this will be my default. Okay, so I want to create another configuration that is that shell thing that we just saw. So here, if I right-click on the part, I can click Add Configuration. So I'll call it Shell Model. I could add a description, and then hit Check. Now you can see this one is, the default is grayed out, and this one is active. And so up top, I can switch back to my main model tree here, and now I'll recreate that shell feature. So I'll do shell again, remove these faces. For multi-thickness, I'll include a set maybe slightly different set this time just for fun. We can see now we have this nice shell feature just as you would expect. Except if I go back in configurations and double click my default, I can switch back here. Now I'm back to my original part. So what happened? How does this work? Well, if we go back to the model tree, you can see that I have the original boss here, those two loft features, and then this shell model that we just created is suppressed, or it's still there in the model, like the definition still exists, but it's not a part of the model definition or the active model as it is. So basically you can hold on to a feature that you don't want to have without completely deleting it. We can go back to configurations. If I double click on shell model again, then now we can see the shell is unsuppressed. So this is functionally the same for this simple case as just clicking suppress in this little pop-up menu, or unsuppress, which I'm getting to by right click, of course. But by doing configurations, especially if you have a bunch of different changes like this, say for example I wanted to enable or disable all the fillets in my model, you could quickly store that as a configuration here and switch back and forth without having to constantly right click and hit suppress and so on. So it's not a fundamentally important feature, but it can be a great time saver if you use it correctly.